Hello and welcome to Buildings of Tomorrow. My name is John Lester, and in today's episode, we're talking about the BMS system, the building management system, and its role as the core of the smart building. I'm joined today by Dario Incorvaia. He is the global head of BMS software at Siemens Building Products, which is in Smart Infrastructure. Dario, thank you for joining us.
Hey, Jan, thanks for having me today. Happy to be here.
It's my absolute pleasure. And I'm excited to talk about this topic because, in this show, we've talked a lot about a lot of different topics when it comes to building technology, let's call it. And the building management system is one of those core aspects which we haven't really touched on. Let's start right at the start of the topic. Can you give us a very quick introduction for everyone out there so we're on the same page? What is a building management system?
Yes, you said it. Definitely BMS. Core product, a core contributor of buildings, of digital buildings of today. To explain what a BMS is, let me give you some example about what needs our customer are having today that could well explain why we need a BMS in the first place. So our customer have many challenges. They have buildings, and those buildings, they have many type of devices in it. They have devices from the building automation, heating, ventilation, air conditioning, but they do also have devices to control the safety of the people, for example, in terms of fire protection, but also security, video cameras, intrusion systems, access control. But you can also extend to meters to control the consumption of the energy, and then you can extend it to many more devices of any type of discipline, thanks to the industrial protocol like BACnet, Modbus. So all of those devices finally are there for a purpose, individual purpose, but all in all, they are there to keep the building safe, comfortable, secure for the people that are inside the building or for the asset that are inside the building. Our customer need an easy way to make sure that the buildings, doesn't matter what is in it, they really can perform at the best of their capacity. But in addition to that, they also needed to be compliant with a lot of regulation in the different industries, which is also a high challenge for our customer. And last but not least, all those devices that I mentioned before from the different disciplines, they are now generating a lot of data every single day. Now, data do not really create a big value if they cannot be attached to a meaning in a way that the customer and the operators of the customer can really do something with those. So that's why we need a BMS. A BMS is finally a software system, and then you can find different type on the market that is able to connect all the dots, connect all those different isolated words that they start as isolated and bring them to a single platform that can be given to the customer to create value out of them in order to make the building high performance building in all the different KPIs that the customer is looking for. So then this is what a BMS is.
Okay, perfect. So it's something that takes, as you say, there's thousands of devices in a building, especially the newer build, the more digitalized that building is, the more devices. Something to bring them together, to make them usable, to make them operable, and to help the operator make sense of all these different systems. With that making sense, making sure they're fulfilling their requirements, whether it's regulatory or the expectations from sustainability or energy efficiency. And I like the last one because I think that's something we'll talk about a little bit more further into the conversation. Is that devices creating data on an island are useless. Somehow you have to bring all that information together, and even though that's the first step, then have some way to make sense of that data and use it effectively. So you need a system in the middle, almost as part of the stack to collect that information and to use it effectively.
Yeah, sometimes, I like to say that a BMS, which stands for a building management system, in reality is a bridging systems. So the B stands also for bridging because it's also very interesting to have a system that from one side that show data, but on the other side also creates interaction between those systems, which is really extremely important for our customer to really glue those systems, create a single value for them out of that.
And that's a really important distinction as well because, analyzing data and generating insights gives you ideas of what you could do. You still need some way to actually make that action happen, right? So you need a system and you need the capability to then, if you decide you wanted to change something, you actually have to change it. You don't want to run around manually shifting things. You need something to help you go through that process and make the changes, especially in a day like today. And we'll talk about this as well. So quickly, this is essential to have this automated in some manner. That's a great start. I like it very much. You mentioned there how the BMS is central, and you mentioned lots of different disciplines. In your opinion, is one of the core functions of a building management system the ability to bring these disciplines together, to amalgamate them and put them in one place so that you can really use them together, not individually?
Well, in my opinion, yes. I mean, traditionally in the market, also in the last decades, you have a specialized BM system. Very much BMS start from the building automation world. That was one of the core asset there. But then you find also some of different systems like a DMS system, danger management, so very much focus on fire safety and security. Or you can go to SMS, a security management system that are much more focused on security discipline like video surveillance, intrusion, access control. And you find many companies providing each of those individually, and then also giving to the market great products. Personally, I believe that all of those make sense, but when they come all together, and then you have a single platform that can, in a way or another, put all these things together, interacting, that creates higher value to the customer, because finally the customer is also dealing, as I said before, with many systems from the hardware point of view, but now also more and more from the software. And then it's quite challenging for a customer to deal with so many systems, because this also generates more need for buying, training, maintaining those, and those are final higher costs the customer is not always willing to entertain. That's why when you have a system that is able, in a reasonable way, to still be very well specialized in the different disciplines with the modular approach, but at the same time to glue all these disciplines together, that was where the value is increasing, because finally it gives a better means to the customer to operate with the buildings.
Yeah, definitely. And I think for you and for many of us that have ever visited a site, an operating site, and you go to the facility management building and you have 4 screens with 4 keyboards and 4 mice sitting there for all the different systems, you can imagine the benefit it would be if you can start to bring them together and turn those 4 screens into 1 screen. This makes a daily operation so much better.
Imagine, Yanni, if you want to create a weekly report out of the building that is listing all the alarms or even in the building. If you have so many systems to deal with, then imagine how many times you have to go in each system and try to create a setup of report. At the end, you can achieve the goal, but then to put all this data together to really create a unique view of what happens is quite challenging. And that's really a pain point that our customers are telling us very frequently now.
Yeah, perfect. I like that. And let's continue it, because you mentioned before that building management system, or BMS, can also stand for bridging. Give us an idea of what you mean when you talk about, once we have those disciplines together, that bridge between the systems and that data aspect from a management perspective.
Well, let me give you a couple of examples. Like if you work for the building owner, or perhaps you're even belong to a service company that is working with the owner of the building to maintain the system high level in terms of maintenance. At the end, one of the key information you want to search to find in the building is what are the conditions, or somehow the fault condition that are at the moment visible in the building, so that might require you some attention in order to plan some maintenance activities. You want to have a single access point to the building in order to get all these conditions that you can work on. And the bridging part is there because then with a single platform, you can really access all of those in the same way, rather than trying to go in every single and find those information. This is one example. Another example that I like to mention is the example of the following. Nowadays, the topic of energy management in the buildings, not only in the commercial building, but in any building, is becoming very important, right? Because we know the needs of our world to require more energies for our facilities. And then it's very important to keep those energy consumption under control, but also to optimize the energy consumption during the days. Now, to achieve this result, you need try to simplify, but you need 2 things. You need a system that is able to monitor the consumption, but you also need a system that is able to analyze those information, and finally create actionable items so that you can change the behavior of the building in order to get closer to what is the so-called optimum. Now, a BMS that is able at the same time to monitor those conditions in terms of energy consumption and then give you the ability to implement action is very available. And that's the type of bridging things that you can do. While if you have all the times different systems, then you have somehow to export the learning to the execution, which is of course technically possible, but it creates a little bit more hurdles to our customer and also to the operators. So those are two examples why the bridging part is quite interesting and also creates higher value. And then I can also make a more example, especially when you have to interact with some protocol or devices that just speak generic device that speak a protocol, Modbus or PC, backnet, you can name them. Those are usually are very simple devices that do not have a lot of intelligence inside, meaning that they cannot really have analytics engine in it. And then if you on top, you can put a system that is able to get or read data from a side and then create interaction logics and then can send actions or commands to other system. That's also very powerful because it can keep somehow reasonably cheap and simple the single devices, and then you can move the intelligence in a programmable way on one level on top of it.
Yeah, I like that. The last example that you gave where we are seeing more and more devices that are connected at a simpler level. But as you say, those devices are created for one single purpose. They do one thing and they do that one thing well. So you need something to elevate it to that next level where they can then act as part of a system and use their ability to interact with the other devices within that system to be able to give you that next level of control. And then the point you had before that, which was you kind of need to make a connection between the brain and the nervous system and the muscles, right? And if you have one without the other, if the muscles aren't told what to do, or the brain thinks but doesn't then pass that information onto the body to make changes, then nothing happens in the end. You come up with great ideas, but there's no change in the physical world. And I think that's a really important step. And I'm not sure if within that analogy, if you have an idea where the BMS would sit, but I guess it would either be the brain or it would be the nervous system. It would be that connector between the thought process and the ideas and the actual physical action after it.
I like that analogy, Jan. It's a good one. Yeah.
Perfect. So that's the BMS that we had today. And I like that conversation because in the end, I think often within the industry, when we talk about BMS systems, obviously the technology has moved so far in the last 10 or 15 years that we need to kind of recalibrate what we imagine a building management system to be. What's next? Technology continues to move. We see now IoT being rolled out more extensively within our industry. We see cloud capabilities and this data skill that we just talked about quickly expanding in our industry. What's next for the BMS?
Well, let me follow up with your analogy about the brain and then the rest of the body. Historically, the brain, as you said, was in the BMS, right?
Yep.
And then you made a very good example about how the body works. What is happening now is that the brain is becoming more distributed in different pieces of the building. It's not anymore only on top, right? On top of the system. Like you usually describe our building like a pyramid where you have on the bottom the devices, then on the center you have some of the controllers or PLC, and then on the top you have the software. And then historically the brain, you can say, was on the top in the BMS. Now what we see is that also thanks to the new technologies, for example, cloud or IoT devices, we see that the brain, we cannot say anymore that the brain will be only on top. We see that devices are becoming smarter and smarter, able to connect with other systems at any layer, so either among them directly or among different layers of the buildings, meaning that you cannot just put the intelligence on the top. But we also see that thanks to the cloud technology, you can distribute also some in different systems. For example, you might have heard about edge devices or edge computing systems, where you have distributed, for example, in a smart gateways of different kind, close to where the system are not only the connectivity part, but also some intelligence to even do some execute some a sophisticated piece of software. And then, of course, with the cloud, you can bring a lot of data in off-premise, and then there you can leverage from somehow big data and also with artificial intelligence algorithm, you can also inject and create additional meanings to the data that you collect individually for every building. So one strong trend is definitely coming from the technology about this IoT and then the cloud that is not removing the need of a BMS, but is changing the way a BMS can be offered to our systems. And what makes me very much excited is that this can create a lot of new opportunities for our customers. And then I'm very happy to try to provide those opportunities with new way of creating BMS in the future. Another element that to me is also important, and we see it very much when we talk about, when we look at the project specification of our customer. While traditionally, we'll in those project specifications, we could read, your system has to have this feature A, B, C, and D. Then system number 2, and then A, B, C, and then every system was described in terms of the functionality that those has to bring. And we talk about OT, operating technology there. Nowadays, we see much more a customer describing not only what the single system has to do, but even more how the system has to interact with each other, and how those systems has to interact with some of the IT infrastructure of the building. Because those systems now have to be part of the building, not just somehow connected in a way or another. And that's also we see a shift from what we call OT, operating technology, to IT, information technology, which is also very interesting because is forcing us to change the way we create our products, and also the type of functionality we need to put in our product, which forces us to have a stronger, harmonized type of connectivity among the different layers, not anymore a sequential from the bottom to the top. But at the same time, also somehow open interfaces so that the ability to exchange data to the different system on-premise, but also off-premise, and also between off-premise systems, for example, cloud to cloud. So those are very visible trends that we see in the market. For sure will, from one side, impact, but even more importantly, we create much more opportunities for us and for our customers.
Understand. And I'll quickly just try and recap some of those because they're really interesting. And today we're not going to be able to talk about all of them, but I think that we need to, because first you mentioned about flexibility. So the technology now is starting to enable us to decentralize some of that brain function, some of that control function. And I could imagine this would give a customer and the people designing the system and deploying the system more flexibility to make sure it fits really specifically to the requirements of that building. Then you talked about cloud capabilities and cloud connectivity, and this absolutely links to connectivity in general and how all of the great things we talk about with data and data analytics and the big data, the data lake approach. Connectivity is the first step to achieving that. So the BMS obviously is a huge part of that connectivity process. And then I like the last one that you mentioned, where we kind of have to, as an industry, also start to shift our understanding away from, this is what the thing that you install should do, and more towards this is how the system or the product that you install works with other products and other systems. And also this is maybe it's more outcome focused, to say this is what we want to achieve. What's the best way that you can propose to achieve this outcome, this goal for the end customer? I think that's all three of those are huge shifts for us as an industry. Dario, if we start one of those, we'll be here for the next hour. So what I might do is say thank you so much for joining us. It was an absolute pleasure.
For me too, a very, very interesting discussion.
Awesome. And it's not going to be the last, I can tell already. So those three topics that we just talked about, the flexibility, the cloud capability, giving us new ways to deploy the intelligence, new ways to connect systems. And then the third, trying to shift our thought process towards an outcome focus and trying to understand better how systems interact, more importantly than my box does this. They're three great things. So I'm sure that we'll have some good conversations in the near future.
We will.
Absolutely. So thank you. And thank you to everyone else who is listening or watching. Feel free to like, comment, share on this episode. Make sure you subscribe wherever you're listening or watching. Check us out and make sure that you keep your eye open for new episodes because they're always coming every week. So thank you, and we'll see you again soon.
Bye.